our project that we received funds was to deal with a very important crop in Africa. It's a root crop, it's called cassava, and it has a very important role for food security for many populations in sub-Saharan Africa. But it's a root crop that spoils very quickly. 2 days after harvested, it's no longer suitable for human consumption. And we received this grant to improve the machinery that's used to process this root for long-term storage. So my role in this research project was not only to lead the research, but to implement a methodology which is called simulation-driven participatory technology development, where we use computer simulation and we work with the main stakeholders, mainly the local equipment manufacturer and also those who operate the equipment.
My role in the research was to translate the main design that was provided to us from Dr. Marcelo in the UK.
So the challenge to process this crop, this root, is that it needs to be dried, and that's a very energy intensive operation. And the dryer that's commonly used has two problems. One is very low energy efficiency and the other is non-uniform drying. We developed two solutions. One was a stirrer to continuously move the product on the drying bed, assuring then the uniformity and also a better contact between the hot air and the product, and that improves the energy efficiency of the dryer. The second solution was a solar water heater to preheat the drying air. So the energy needed to heat up the air that promotes the drying becomes much less.
The benefits of collaborating with an institution in the UK, several. But mainly, we had an opportunity to access current methods for analysis of designs before we get into manufacture, eliminating trial and error in the product development process. Components in design, we had components in manufacture, and the skills required to produce this new product and the experience and added experience with our workers in the development of this new product, which had never been done before. This was in itself an innovation.
The collaboration with the equipment manufacturer in Tanzania really increased the impact of this research because it allowed to build this equipment to other dryers, to other users, and also to assure the long-term maintenance of this equipment. The main outcome of this project was really this application of what is called the simulation-driven participatory technology development. This methodology was implemented in this project and allowed us to come up with a prototype very quickly in a very low cost that could be manufactured locally and maintained by the partner.
The impact that the project had on our organization, first of all, it was the enhancement of international collaboration. The other component was the fact that we enhanced our capacity for local manufacture. Most times, the equipment that is required for agro-processing and value addition is imported from abroad. But this time, this was something that came from design, development, and manufacture, and building our internal capacity, not only for innovation, but to supply our local producers to eliminate the need for imported machinery.